Welcome to the shop. I'm continuing NQALHA Production Run 4. Each NQALHA has 75 individual machined parts and I'm making 10 units. So that means I need to make 750 parts. So time to get going. In previous videos, I've showed the entire setup process in great detail. I'm going to kind of skip that right now. If you're interested in how the Tormach is set up, I go to like the first or second video in Series 4 and I'll show that. I'm probably also going to be doing a video just talking about the Tormach and the custom-made enclosure and not really making any parts. So this part that I'm making is using the standard setup, which is put the blank in the right vise, drill the holes, move over to the left vise, and cut the outside profile with the piece mounted on a tooling plate. So once again, work offset 1, 0 set at the back corner, left corner of the soft jaws at the back of the ledge in the soft jaws. And this is work offset 3, G56, 0 set at the back left corner and the top of the tooling plate. So I've got the tools loaded in the Tormach tool changer carousel, and I'm not completely prepared and ready to go. I do need to set the 0 using the Tormach automatic tool setter. And one thing you got to watch out for. Here's a way to make a mistake, and I hate making mistakes. The power drawbar on the Tormach is air operated, and it has 2 positions, open and closed. In the closed position, there's an R8 collet in there that is sucked up into the spindle nose. In the open position, the collet is protruded beyond the spindle nose, resulting in an inaccurate measurement if you forget to close the collet and then go ahead and do a measurement of Z position. You end up with an inaccurate measurement. Now, since the control software knows whether the collet is open or closed, there's actually a measurement and feedback mechanism inside the thing. It seems like it would be easy for the system to notice this and flag an error, but no, it just lets you make the mistake. So, what can I say? I'm using aluminum extrusion, which is pretty much standard. Just about all the aluminum parts on the NQALHA are made of extrusion. And I'm going to set up the aluminum cutting shop saw. Measure twice, cut once. Go over to the setup sheet, check it again, 4.06 by 3.5 by half. Using WD-40 as a cutting lubricant makes a exceptionally nice surface finish, almost no burr, but I still, I still hit it with a Scotch-Brite because why not? Okay, now change to G54. I typically set Z0 on the top of the blank most of the time, and then other times it's different. So, okay, standard operating procedure. Even though this is a known trusted tool path, known trusted tooling plate, made many, many parts with this, I treat every tool path as a new tool path if I haven't run it that day, because memory can be faulty in this business. I haven't made NQALHA parts for many months, and memory can be faulty. So hand on the stop button, pay attention. Go into single block mode. Verify that the rapid feed stops approximately an inch above the surface. This is put in by the toolpath program, BobCAD or BobCam, and it kind of acts in single step mode as a nice way to do a sanity check. If I see it blowing through that 1 inch and heading for the part, I can usually hit the stop before bad things happen. Okay, so that's looking good. 2,500 RPM, 10 inches per minute, fast peck. My peck cycles are, well, the feeds and speeds and peck depth are optimized to produce short, thick chips that break well and don't form a rat nest on the drill bit. And the drill bit comes out clean, all is well. This is a fairly simple part, and it's going to go pretty quick, I expect. It's going to go pretty quick. Single step. Verify pre-feed, verify feed, (5140) RPM, and this one is doing a full peck cycle. I'm not sure why. Probably a fast peck would be fine, and I may go ahead and modify it, or maybe not. I might not even care. As the project proceeds, I continue to refine and perfect. Okay, pre-feed correct, feed correct. I continue to refine and perfect my tool path, and this results in some of the new tool path and parameters being different from some of the others. And when I first started, I used the normal peck cycle for everything, and little bit by little bit I've been moving to the fast peck cycle because it's a little faster and it seems to accomplish the same results. I believe the full peck cycle that does a full retract is only necessary when drilling really deep holes, and I do use it on my very deep holes, but for most of my normal holes, I'm moving toward the fast peck cycle. So now I'm going to do some power tapping. And as I said before, there's two reasons that I don't use the flood coolant for power tapping. First of all, the compression tension tapping head is really long, and I'd have to reach in and readjust the nozzles to get the flood coolant down to the tap. And second of all, the flood coolant just doesn't work as well. The I prefer using Tap Magic for aluminum. It really works exceptionally well. So I manually put a pause, an M0, into the custom post processor so that the machine would pause and I'd have a chance to apply the tapping fluid. I'm using spiral taps, and they eject the chip upward out of the cut. This works really well on blind holes, and yes, I have a lot of blind holes in the project. It also works just fine on through holes. No problem on through holes. So this is a 1024 tap. Single block, verify pre-feed height. The Tormach machine with the compression tension tapping head actually can tap small holes. I have a couple of 440 holes in one of the parts, and it taps it very reliably without tap breakage. So now I could deburr this, put it over on the tooling plate, and then go cut another blank while the machine is idle, but that's a time waster, so I'm going to put this one aside for later deburring and go cut another blank. By using this sequence of operations, I can end up minimizing idle time. So now the toolpath is proven. I can pretty much stop paying as close attention to it and just let it do its thing. Gonna deburr this guy with a Noga hand deburring tool. And yeah, I probably could use a cordless drill, but this doesn't bother me. It's no faster, and the little bit of hand wiggle is not a problem. The third operation on this part will be to drill a hole perpendicular in the end, and that's going to require the special tall vice jaws, because clamping it in the normal soft jaws with the short jaws, I can't really control where that point is, so I use the taller jaws and then indicate at the top point surface to try to get the best accuracy. So this one goes on the pile. I try whenever possible to do as many things as I can in parallel, because it gets the job done faster, and otherwise I'd just be bored sitting around watching the machine. even though the chips are ejected up out of the hole, and sometimes they just fall off on their own, I like to use a little bit of air to kind of give them just a little extra helping hand. I gotta be careful, because being too aggressive with the air will force the chip back into the tap, and I've broken a tap doing that. So now, take this blank off. It's wet, put it on the paper towel. New blank in place. Move over to the tooling plate. I'm using, well, I'm dropping. I'm using aluminum washers I just finished the last of the 10 parts, first and second operation. Now it's time to set up for the third and fourth operation, which is going to be drilling a perpendicular hole. I'm going to be using work offset 2. Now, in my normal work, I use work offset 1 is the right vise at left rear corner. Work offset 3 is the left vise at left rear corner. But for this special setup, I'm going to be using work offset 2. And get out my El Cheapo Harbor Freight, surprisingly good. I mean, this tool really works well for such an inexpensive tool. El Cheapo air ratchet. Much more pleasant than using a hex key. Even my nice set of T-handle drivers don't fit in the vise, and so the air ratchet really makes things a lot nicer. So here's my special tall jaw. And both of these surfaces were machined on the Bridgeport to perpendicular. And then I'm going to wipe off the surfaces here just to make sure that I get a good fit. Inspect everything to make sure it's free of chips. And then give it a little bit of precision alignment just to make sure that it's seated against the vise surface. Then the front jaw with this setup is shorter because I like the visibility and it holds the part well enough to get the job done. Back to the Heimer indicator, and then go over here and make sure that I'm in G55, work offset 2. Even after all the thousands of parts I've made, the jog wheel does not feel intuitive, and I often just jog the wrong direction. Maybe someday I'll build a better one. Now, you may have noticed when I was jogging the table using the jog wheel that I kind of looked over at the screen over there. Here's another mistake you can make using a Tormach that will ruin your day. Well, maybe not ruin your day, just kind of annoy you a little bit. That The jog shuttle controller, I don't know if you can see in the video, it's got this center wheel, so you can do both continuous motion and step motion. So I do the continuous motion slowly to get the Heimer almost close to zero, and then if I want to get it that little extra bit, I use the step wheel. Well, the step wheel can be adjusted to truly gigantic steps. It goes all the way from a tenth all the way up to 100 thousandths. And if you're not paying attention and you're used to running the wheel in tenths, and it kind of inadvertently, for some strange reason, got set to 0.1, bang, there goes the Heimer tip. Ask me how I know this. There are so many ways to make a mistake in CNC machining, in machining just in general. Kind of reminds me a little about my profession, my engineering profession of software engineering, where the common saying among software engineers is that software isn't hard. It's thousands and thousands of simple steps, and each individual step taken in isolation is really easy. It's trivial. It's so easy a machine can do it. The problem is you have to get every one of those thousands right. And if you miss one, well, you're going to have a problem. And CNC machining kind of reminds me of that a little bit. Got to remember every single step, like going over here to feel the spindle nose and make sure that the collet is not protruding out. Make sure that I have sufficient clearance so that the spindle doesn't hit the back of the tall jaws. Make sure that the feed rate left over from the previous milling operation is correct, because for some unexplained reason, Tormach uses the last programmed feed rate for machining operations. It uses that feed rate for probing operations. Seems wrong to me, but okay. So now I believe that I am set up correctly to do the third and fourth operation. Let me get the speeder upper tool. So, gonna press the part both against the bottom of the vice jaw and to the side. Z0 reference is on the bottom jaw of the vise. And then I need to look at my tool 36 and 38. So I'm going to have to load up tool number 38. Tool number 36. This is going to be the holes for, once again, holes for some pressed in bronze bushings. And in order to get a nice tight press fit, these are going to be reamed holes. And as I said before, I could probably get away with drilled holes, especially if I drilled in 2 steps, but you know, it's only a few extra seconds of cycle and produces a really nice pressed fit. So here we go. Standard operating procedure. Hand on the stop button. That looks sane. Single block. That looks sane. 1 inch above the surface. Pre-feed height. Feed height looks correct. 1500 RPM, 10 inches per minute, using a fast PEC cycle with, I don't remember what the PEC was, but I have switched to using fast PEC for all of my shallow holes. I still use the standard PEC for my very deep holes. I have a few holes that go almost 2 inches deep with a small diameter hole. And so that's looking good. Now it's time to flip it. Flip it good. Ba-na-na-na-na, bam, bam, ba-na-na-na-na. Flip that part. Given that the part distance between holes is 4 inches, it seemed ridiculous to attempt to do both holes in one operation. That would have been a tremendous lot of drill stick out, reamer stick out, and hey, it's just a flip. So that completes the machining on this first part. I'm going to turn the camera off and then finish the rest of the parts off camera. I finish these parts in the vibratory vibratory polisher, using plastic pellets that are designed for finishing aluminum. And I think I showed probably in video 2 of this series what the little polisher looks like. It's an El Cheapo Harbor Freight unit, and it actually works, and it's done thousands of parts, and it's a pretty boring machine. It's pretty loud, and you really aren't learning much by watching me throw parts in a vibrating polisher. So that does it for today. Thank you for watching. It's been fun.